HPI, High Performance Interconnects, we believe at Orion and some of the research we've done that this is now actually truly a market. There are more than one competitor. There are multiple methods, ways to do this, to get there. Without HPI, you really don't have a cluster, at least a high performance one. We're talking about the very tip top of the market. And this is important. In our 2016 HPC survey, we found that a considerable number of folks, more than 40%, were going to be spending more money on interconnects this year than last year. And very few, 15%, were going to be spending any less. So to give you a little bit more flavor for how we see how we're cutting this market, really we're talking about 100 gigabits and up in terms of throughput. It's MPI, it's multi-rack. Very few single racks are going to use these high-performance interconnects, although some do. Three types of HPI. Why do I keep looking up at that? Because I can't see that if I look at it. So I'm going to look at this. Ethernet, right? That's where everybody started. That's where a lot of folks still are. Sold by a whole boatload of providers. Pretty much everybody and their dog has some sort of Ethernet solution. It's been, while it's there in bandwidth, you can get 100 gigabit Ethernet. It's not there in terms of latency. Latency is measured in the milliseconds rather than the nanoseconds. Proprietary stuff, Cray, SGI, IBM. You have to buy their system in order to get this stuff. Pretty high performance. Intel's a new entrant into this segment of the market, although without an accompanying system with the OmniPath stuff. InfiniBand, Mellanox has emerged as the de facto leader. Highest performance based on published numbers with 200 gigabits today, 200 million messages, 90 nanoseconds latency. And by the way, if any of you come down with a head cold, I'm patient zero for that. So you can thank me for it, because I've been suffering with it, particularly yesterday, but somewhat today as well. So, key differences in HPI product maturity and position. Ethernet has been around forever, as everybody knows. There's still a lot of installations, but you don't see them anywhere in the top 50. You don't see them, you barely see them. I think there's 3 systems in the top 100. They're really falling off the charts. And it's latency that's doing it, not bandwidth. Okay, let's get to the fun stuff here. Intel OmniPath architecture, they've come up over the past year. You now see them in the top 100. I think that's 10 systems total. Still in their infancy, not a lot of installations, not a lot of big numbers out there, except they do have some large installations. A handful of customers with some big names, but some big systems out there that are coming into production. And we're going to talk about some of the claims going back and forth. There's a great FUD war going on in high-performance interconnects. InfiniBand has been around since the early 2000s. Thousands of customers, millions of nodes. Now makes up a large proportion of the top 500 list, 187 systems, slightly down from last year. It's really kind of synonymous with Mellanox these days. And as you can see, they hold up well versus even the proprietary stuff. Cray, Aries, Gemini, when you're talking about the top 50 systems and the top 100 systems. Key differences, onload versus offload. And this is where all the yelling and fudding is centering on. Onload is where the CPU handles all of the network transmission stuff. So all of the packaging and all of that gets handled by the CPU. And that's something that Intel OmniPath architecture has, along with Ethernet. That's the mechanism they use. Also, old Unix systems did that, where you had the CPUs handling all of it. Offload. This is where the HCA and the switches, but primarily that host interface card, handle all of the network stuff. So the CPU basically just sends it down the pipe, and all of the work is done by that HBA. Mainframes do this with their assist processors, and not a lot of other systems, but offload is a very popular thing. Actually, no, I take that back. Most of the proprietary stuff is offload. The Cray, Gemini, and Aries, and SGI, Bull has an offload architecture as well. Offload details. So it's all the network protocols, as you can see up here, the link layer, network layer, transport layer, MPI operations. All of that stuff in offload is handled by that network card. And as we've learned over this week, more and more of that is also being handled by the switches, so it's kind of compute anywhere. And with offload, all these operations are handled by the network hardware, adapter hardware. Onload, well, it's the opposite. Everything's handled by the CPU, right? The network adapter they have is just sort of dumb wire that takes everything to the CPU to handle. And Intel would make the case that we got lots of cores, right? So why not use them? Especially when you talk about Knight's Landing, we have a heap of cores there. So why not let them handle all of this onloading? Let them handle all of the network protocols. And when the cluster's small, onload versus offload isn't that big a deal. Do you like the head node? I thought that was kind of funny. No? Yeah? Yeah? That took me a long time in Illustrator to do. You're going to see it again. But when the cluster gets big, this whole onload offload question is going to become very serious. What can happen is when you're doing things like scatter, gather, all of that sort of stuff, the collective stuff, what happens to the head node? When it's sending out all these messages and then receiving all this stuff back at once, right? It's going to get pounded. When you have internode communication, the CPUs are going to get pounded. And how much of your actual application processing do you lose in that? Again, I think as node count increases, performance of onload will drop. More messaging, more pressure on the head nodes. Message sizes are variable, and that can cause some problems as well when you start talking about big messages. Node counts, as I have in the chart up here, are increasing significantly. Average node count is now 6,000, and that's not going to get any smaller. MPI is not all that parallel, which is something that surprised me as a guy who doesn't know all this much about MPI. I haven't done any of it, but in asking around and in doing research, there's a lot of stuff that it doesn't parallelize all that well. And when you're using CPUs to handle this, you're basically limited to the speed of your fastest core because it doesn't go out and use all of the cores for a particular transaction. And that gets a little tough when you start talking about, or when you're talking about things like the Knight's Landing processors, because their core speed is pretty slow. And that same fact, that doesn't have really any bearing on offload speed. There's a huge FUD war on this. Intel has really been firing a lot of shots, and I've been watching with great amusement, but there was an article that's referenced there, and will be in the slides, from the next platform that just had so much stuff in it that I was forced to deconstruct it because I just didn't believe it. First of all, the first claim that they're making is that the cost of interconnects, that their cost for their interconnect, the Intel OmniPath, is significantly lower, and that the cost for a fabric, which they're calling InfiniBand, is about 40% of the total of systems. And first of all, that kind of information really isn't readily available to researchers. Second of all, tech follows a pattern, right? When you have a new product that comes out, you're going to hit it at about the price point of the former product that it replaces. It happens in PCs, it happens in servers, it happens in cars. It happens particularly in tech products, though. You can't move that price up. And so I think that both are probably going to be on par with pricing, although they will battle back and forth about who's cheapest, best TCO, and all that kind of stuff. But I don't think that there's really a cost advantage between Intel, OPA, and InfiniBand. More of the FUD war, talking about, and this is all from that same story, but talking about how they're faster in this and latency and that and the other thing. What really gets interesting is when you look into the notes, little fine print that Intel has to put on these things because their lawyers demand it. When you blow that up, you see some interesting stuff. DAPL is the key on this particular thing in that the way that they're using DAPL will constrain the InfiniBand system from offloading, and from offloading very well. And, well, gosh, if you're doing that, if you're hobbling it, well, then I guess you can't be surprised by the preceding benchmarks numbers. And I love that line at the end. Software and workloads used in performance tests may have been optimized for performance only on Intel processors. At least they say it, which is good. This is the one that just kills me. Here we have what they're showing. On the left is Intel, on the right is EDR InfiniBand. And what they're showing here is CPU core utilization, right? At different number of core pairs. And it's really, really interesting to me that you could do a benchmark as a huge vendor and essentially say that because the InfiniBand systems are at 100% CPU just doing network, they're using 100% of the CPUs. If that's even remotely true, well then half or 187 of the systems on the top 500 list are useless, right? So that kind of shocked me. What they did, and again, it's in the fine print, but they're using a CPU polling mechanism to figure out what the CPU cycles are at, or what the utilization is on the Mellanox box. And that has nothing to do with the network traffic or what it's doing, but it has a whole hell of a lot to do in pegging that thing to 100% utilization. Other thing is both Intel and Mellanox have benchmarked OPA at about 65% CPU utilization. And you're using 65% of your CPU on network comms, you're losing 65% of your CPUs. They're not doing applications. So we did did I update this for HDR? I did. Take that red note out to me. In taking a look at this for this presentation, you're looking at 100 gigabits per second for OPA, 89 million messages a second, about 93 nanoseconds latency, which, 90, 85, whatever. That's getting low enough to where you're below the cycle for MPI instructions, so that the latency doesn't really matter once you're getting that low. Intel, I had to change that, by the way. I put the little asterisk there because the first number they'd given out on that was 150 million messages a second. Yes? Oh, they brought it back up? Are they talking about it? Because I didn't see it when I looked for it. Oh, aren't you Mr. Smarty Guy? Go ahead and showing me on your browser where it is. You say it's 143 now? Yeah. Okay. But it is depending on the CPU. Yeah, it's true. It's going to be. Okay, I will update that. So 143 versus 150 versus 200 million a second. Pretty big numbers. HPI roadmaps. The InfiniBand roadmap is published, which is nice, and it shows that we're going to be seeing NDR. There are 200 gigabits now. We're going to be seeing NDR, which I think is going to be 400 gigabits, but no one's really saying. Probably around 2020. If you use a ruler on that roadmap, you can kind of get there. I can't find a solid Intel OPA roadmap. Did you find one? Okay, I'm kidding. So I'm not sure exactly where they're going to go or when they're going to be there. Ethernet roadmap is showing 200 gigabits the next couple of years. But again, well, I don't want to say they can't beat the latency problem, but they really haven't beat the latency problem yet. Never say never. So at OrionX, where I work, I'm sort of the lead analyst, I guess I am. We did a rating and ranking of vendors and the different HPI solutions out there. And we're doing this a little bit different. Think of this as sort of a different kind of Gartner Wave, and you'll see it on the diagram next, or the Gartner Quadrant or the Forrester Wave. What we wanted to bring into this was market presence, market trends overall, that's sort of the average of those. But we wanted to bring in the customer readiness and customer needs. How well do the various solutions, the three solutions, match up, right? And for instance, customer readiness, Ethernet, yeah, they're ready. They got it all ready. That should probably be a 10 or a 9.9 if we did that. And the same product capabilities. Right now, InfiniBand is way on top in terms of performance, so that's a 10. I mean, they've doubled up everybody else. So overall, you can see the numbers. And what we did to make this kind of cool looking and to explain it is put it on this spider chart. And if we were redoing this chart today, we would probably, I think Mellanox would have a little bit bigger lead on this because this was done before the 200 gigabit announcement. So, that brings us to the end. Questions, comments, concerns, complaints? Yes? I think, though, that once you get under 1 nanosecond latency, and I'm in this presentation, I'm only talking about the very top end, right? That once you get below 100 nanoseconds, that you're probably okay because your MPI commands have a higher latency than that. The other thing, though, and this is sort of the overarching larger part, I think that we're going to be seeing much more need for more and faster high performance and more bandwidth. We're all talking about AI, and we're talking about machine learning, and we're talking about all this really cool stuff. Customers aren't there yet, particularly on the enterprise side, and they have to get to big data before they can do AI. And that's where customers are right now. In our survey, on the enterprise side, they're trying to get to where they have control over their big data. When they have control over their big data, they're going to find out that they need a huge amount more bandwidth. And that's what I think is going to happen. And as these worlds of HPC and enterprise cross over farther, we're going to see more and more customers out there, particularly on the enterprise side, going to the high end. Other questions? Yes? Oh, God, now you got another analyst asking me a question. You're just going to drill me, aren't you? Yeah, he asked if it does, But that's Intel's test on the left. This whole chart here is from Intel, and they're claiming for their own product that they're at 65%. 32 nodes, or no, 28 nodes, running the Ohio State University stuff, benchmarks, and it's their claim, which it seems pretty high to me too. And it's not something I'd write home about or brag about if I were them. But, yeah. Oh, you've got 35%, Michael. What are you crying about? You've got 35% of CPU, and they're getting faster, and there's more cores and stuff. I agree. But at the lower end, smaller clusters, 4, 8, 12, it's better, it's 10%. But what concerns me, what happens when you get outside of 28? I mean, average system on the top 500 now is 6,000 nodes. What happens then? That's concerning.
Maybe they mean 65% of A core.
No, and if you read the disclosure on it, it's 65% of all cores. Well, Gilad, you would know.
So the graph states its number of cores.
Yes.
Essentially, when you measure bandwidth, you measure it between two nodes.
Yeah.
This is Xeon, it's not Knight's Landing?
No, it's Xeon.
This is Xeon.
Yeah. Standard server, 2 CPUs. Yeah. So I agree with you totally, Michael. That's not something to brag about, but they, drilled the test by making sure that, and I mean, that's the other thing that's completely, that I can't understand at all, can't comprehend how they could, with a straight face, say that at the same kind of test that offload is 100% CPU busy. I don't get that. Other questions, comments, concerns, thoughts? Yes?
So you kind of skip the fact that actually they are putting the interconnect so much, but a couple of products. More flexibility, right?
Well, I don't know if it necessarily gives you more flexibility. It's probably going to give them a cost advantage, right? Whether they pass that on or not, they probably will. But I don't know that that's not going to solve any of the problems here. You're still using CPUs. And that network stuff is just dumb copper. It doesn't add anything to it. But it's a good point. It'll probably help on the cost front.
Let's say that for any reason they drop PCI Express from their high-end PCs.
That would be interesting. To me, that would be a lot like IBM back in the day of PCs going with microchannel architecture. They thought they could get away with that and kill the clones with it, and it didn't work. I think the rest of the market is too big now for one vendor to be able to control that way. Because it's basically, they're trying to take all the marbles. They take out PCI. That's going to be really hard to pull off. I don't think they could do it. But it is an option for them. It's an interesting option. Anything else? You sick of this? Yeah, you're sick of this. Okay. Okay, next.